Today we're getting into something really fundamental, electrostatic induction. We're talking about how you can actually charge something up without physically touching it. It's all about electron movement, which sounds simple, but the methods are pretty clever.
They really are. And we'll basically look at two main ways, two approaches to induction, one without using grounding, and then, well, one with grounding. The mechanisms are quite distinct.
Okay, let's start with the first one then. Induction without grounding. So the challenge is charging without contact. What's the setup?
All right, picture this. You have two metal spheres right next to each other, touching. They're both electrically neutral to start.
Neutral, meaning equal positive and negative charges. Lots of free electrons milling about inside them.
Exactly. Think of them maybe having, say, 3 atoms each with a free electron, just as a simple picture. Now, you bring a positively charged rod near one of them, let's say the right sphere, but you don't touch it.
Okay, positive rod comes close. What happens to those free electrons in both spheres?
Well, they don't stay put. Those electrons, being negative, are immediately attracted to that positive rod, so they'll all shuffle over towards it.
Meaning they pile up in the sphere that's closest to the rod, the right one in our example.
Precisely. All those free electrons, or at least many of them, migrate into the right sphere. This creates a surplus of electrons there.
And the left sphere, since the electrons moved away from it.
It's left to the deficit, right? It now has more positive charges than electrons. So the right sphere becomes negatively charged, and the left sphere becomes positively charged.
But the whole two-sphere system is still neutral overall. Just a polar.
Charges just unseparated. Now, here's the really crucial part.
Okay.
While that positive rod is still held nearby, influencing things, you separate the two spheres. Pull them apart.
Okay. So you break the connection between them while the charge is still separated by the rod's influence.
That's the key move. Because now, even after you take the rod away,
the electrons can't just flow back to the left sphere.
Nope. They're trapped. So the left sphere is permanently left with that lack of electrons. It's got a net positive charge spread out evenly.
And the right sphere keeps that extra crowd of electrons, making it uniformly negative.
You got it. So you've created two oppositely charged objects from neutral ones, all without any direct contact charging. Pretty neat.
That really is clever. Okay, so that's one way. But you mentioned a second method involving grounding. This sounds different.
It is, and maybe even more practical in some ways. First, we need to be clear what ground or grounding means here, electrically speaking.
Right, it's not just the dirt outside.
Well, it is often literally the earth. But electrically, the ground acts as a huge, practically infinite reservoir of free charges. It can easily give up electrons or absorb them without really changing its own overall electrical state. Think of it like an ocean for electrons.
An infinite source or sink for electrons.
Yeah.
Okay, so how does that play into induction?
Okay, new setup. This time, just a single conducting object, say, one sphere again. Neutral to start.
And we bring the positive rod nearby again?
Yep. Just like before, the rod pulls the object's free electrons towards it. So the side near the rod becomes negative, and the far side becomes positive because it's lost those electrons.
Standard polarization so far. Now what?
Now comes the grounding. While the positive rod is still held close, you connect the object to the ground.
How do you connect it? Just touch it?
Often, yeah. Touching it with your finger works because your body is conductive enough to connect it to the much larger ground, like the floor, the building, the earth itself.
Okay, so I touch while the rod is nearby. What happens at that moment of connection?
Remember, the far side became positive. It has a deficit of electrons. And the ground is that infinite reservoir.
So electrons will flow from the ground up into the object.
Exactly. They flow up your finger, attracted by that positive region created by the nearby rod. They essentially neutralize that positive charge on the far side.
So the object gains electrons from the Earth. Interesting. Now, to make this charge permanent, there's a trick to the order, isn't there?
Absolutely. Critical sequence. First, you must break the ground connection. Take your finger away.
Before removing the rod.
Yes, you remove the ground pass first. That traps those extra electrons that came up from the Earth onto the object.
Okay, ground disconnected. Then you remove the positive rod.
Then you pull the rod away. The force holding those electrons bunched up on one side is gone.
And the extra electrons.
They spread out uniformly over the entire surface of the object. And because it gained electrons from the ground, the object is now left with an overall net negative charge.
Wow. So you use the Earth itself to pump extra charge onto the object.
That's a good way to put it. You harness the ground to give the object a lasting charge, opposite of the charge of the rod you used.
So let's wrap this up. We've seen two really elegant ways to charge things up without touching them.